So let's take another question for solving Dijkstra algorithm. So as you know, this is Dijkstra algorithm basically used to find out our single source shortest path. So let's say our source is given in this question as 0 vertex as our source, and we try to find out from this source what is the minimum cost to reach each and other vertex. So how many number of vertex are there? 0 to 8. So as you know, I have suggested in the past video also, we will try to make a table here. So whatever source we have taken, first of all, we will mention that vertex as first vertex, and rest all vertex you can mention in any order. So let's say we have written like 1, 2, 3, 4, 5, 6, 7 and then 8. So this is the number of vertex we have in our question, and initially Dijkstra algorithm assumed that source to self distance to that particular vertex will be always 0. So distance to this vertex 0 is to itself is 0, and rest all are at a distance of infinity. This is the initial setup at the beginning of any question. So we have made like this: infinity distance to all, and source to self distance as 0. Now first of all, what is the Dijkstra algorithm states? Take a minimum cost, or you can say minimum cost single source from here. So which source we will select? That is my selected vertex. So which vertex I have selected just now? Because out of all infinity and 0, which one is less? 0 is less, so source 0 is selected my first vertex. So this is my selected vertex. So out of this selected vertex, now I will try to find out the distance from this u to v and distance from this u to v. This is become my u and this become my v, and we will apply same relaxing rule here. So cost of u to v is 4 and this distance is 0. So 0 plus 4, whether it is less than the current cost of v. Current cost of v is infinity. Yes, so 0 plus 4 is less than infinity. So we'll update the distance vector at v by using this new cost. So this new cost will be nothing, 0 plus 4. So distance to infinity will be updated with new value 4 here. So this cost has become 4 now. Similarly, from 0 we can go to 4. Right now cost of 4 is infinity, reaching infinity, for reaching 4 is infinity, but new cost will be 0 plus 8. So 8 is less than infinity, so we will update cost of reaching 4 as 8. Now no other vertex you can reach directly from 0. So out of these two, which one is minimum? So 1 is minimum. So in the next step we will select vertex 1. So vertex 1 will be selected, which has a cost of 4, and from 1 we will see how much cost it takes to move to its adjacent vertex. 1 to 2, it tells you 8. Right now reaching to 1 is 4. So 4 plus 8 is 12. So 12 is less than, right now cost of 2 is infinity. So we will update with the new or less cost. So 12 we can update it here. Similarly, from 1 we can go to 4, and the cost of reaching to 4 is nothing, is basically 4 plus 11, that is 15. But the current cost of 4 is 8 and new cost we are getting 15. So we will not update it here. We will keep having the same old cost because old cost is minimum. Relaxing rule states only update when you are getting new cost as less than already available cost in the cost matrix. So this much we have got. After this step, we cannot go back to 0 because this vertex has already been visited. Now 1 has already been visited. We will mark like this, and out of these two, which is having a minimum cost? So 4 is having a minimum cost. So next vertex that we will visit just now or selected is my 4. So from 4 we cannot go to 0, we cannot go to 1 as per Dijkstra algorithm. whatever vertex we have already visited, we cannot go back. But from 4, we can go to 8. Right now, cost of reaching 8 is infinity. And from 4 till 4, how much cost we have got? 8. 8 plus 7 means 15. So 15 is less than infinity. So we will update the cost of reaching of 8, 15, as 15 is less than infinity. This is the first updation we have done. And from 4 we can go to 5 also. And the cost of reaching 5, this cost was mentioned as 1. So till now, till 4, cost is 8. 8 plus 1, 9. So right now 5 is infinity, but new cost we got as a 9, which is less than. So we'll update it like this. So 9 and 15 will be new updations once we have listed vertex 4. Again, we will draw the table. We will select the minimum one. Which one is minimum we got? We got 5 as a minimum. So vertex 5 will be selected. And from 5, we cannot come back to 4 as already listed, but we can go to 5 to 8. Till 8, what is the cost available? 15. And 9 plus 6. Still we are getting the same cost. So no point of updating it going to 8. Either through 5 or directly whatever cost we have just now, it's a 15. 9 plus 6, still you are getting 15. So this cost, either you update it or not update it, will not make difference because 15 is equal to 15. You are not getting any less cost. 15 will remain same. From 5, we can go to 6. Right now, cost of reaching 6 is infinity. Till 5, we have 9 cost. 9 plus 2 is 11. 11 is less than infinity. So cost of reaching 16 can be updated with new cost which is less, which is 11. So from here, out of this cost available to us, which one is minimum? Which one is minimum? So 11 is minimum. So 11 is minimum means which vertex we will select? We will select vertex number 6. So in this 6 vertex, till 6 vertex, you are getting a cost of 11. From 6, you can go to 2. What is the cost required? That is 11 plus 4, 15. And right now cost is 12. So we will not update it because 15 is more than 12. So we will keep 12 here. No issues. Rest, here also you can write 12 because still we have not visited 2. So still it will remain same. From 6 we can go to 3. Right now cost of 3 is infinity. But if you go through 6, so 11 plus 14. So new cost of reaching 3, you are getting less than infinity, that is 25. So we can update it. Cost of reaching to 7 is infinity right now. If you go through 6, so 11 plus 10, you can update it as a 21. So cost of reaching 7 is 21. And we cannot go to 8. So we will keep 8 as 15 here also. So out of these 4, which vertex will be visited next after visiting 6? Which one having the less cost? So vertex number 2. So 2 will be taken as a next particular vertex. So from 2, we can see what is the new cost where we can reach. We cannot go back to 1, but we can go to 8 because 8 is still not visited. So till 2 we get a cost of 12 and 12 plus 2, 14. Right now cost is 15. So we can update it by 14. So this cost will be now 14. Fine. From 2 we can go to 3 also. And till 12 it's a till 2 it's a 12 and 12 plus 7 is 19. Current cost is 25. We are getting a better cost, so we'll update it. 12 plus 7 is 19. So this cost of reaching 3 will be 19 now. Fine. And what else we can move from 2? We cannot go to 6. We have Now updated 3, we have updated it, we cannot come back to 1. So this is the new cost you got here after selecting 2, 19 here, 21 remains 7, and 2 to 7 is 21, and this is 14. Out of these three, 19, 21 and 14, which one is less? So less cost is vertex number 8. So we will select vertex number 8. So after visiting to, our new vertex selected is 8. Till now, reaching to 8 costing us 14. From 8 where we can go? We cannot go anywhere because 2 has already been vested, 4 has already been vested, and 5 is already been vested. So no more updations we can do for this particular vertex. So 8 we have selected. Now after 8, what else are remaining? One is 19 and one is 21. So which one is less? So 19 is less. So after 8, next vertex selected would be 3. Fine. Because 19 is less than 21. From 3 also you check it. From 3, can you update 7? Yes, we can update 7 because still we have not visited 7. But whether this cost is less or not, we need to check it. Right now, cost of reaching 7 is 21. If we take 3, till 3 we have got a cost of 19. So 19 plus 9 is 28. We are not getting a better cost. So we will not update. We will keep 7 as 21. So 3 has already been vested. 8 we have already done. Last vertex remaining is 7 and that's cost is 21. So finally we got 21 here. Okay. So last vertex will be vesting as a 7. So this is the whole about taking source as 0 and reaching to different destinations. So what is the cost we are getting? 0 to 0 cost is 0. From 0 to 1 we are getting how much cost? 4. Whatever I have circled it. From 0 to 4, what is the cost? We got a cost of 8. From 0 to 5, we got a cost of 9. Okay. And from 0 to 6, we got a cost of 11. And from 0 to 2, we got a cost of 12. And from 0 to 8, what is the cost of 8? 8 cost is 14. And from 0 to 3, what was the cost? 19. And from 0 to last vertex was 7. And its cost is coming after selection is 21. So this is all about the different cost that we are getting from a single source, and source we have selected in this question as 0. So you can get the answer from here. And for getting any path, which path is available, let's say we will try to tell you one thing about you can say what is the path of 0 to 7. We know the cost as a 21, but what is the path of 0 to 7? So we will go into this table and make a pointer here. Okay, we will go one step up. 21 remain 21, so no change. Fine. 7 will remain 7. After this, you can see you go one step up. Here the cost was infinity. So this got changed, but this got changed because of which vertex selected? That vertex number 6. So after 7, you got one vertex which you have listed 6. Now in 6, you go up again. You got a change. Infinity was earlier in this cost. So this got changed because of 5. So 7 before is 5. Now 5 has already been changed, but because of what? 4. 4 is not changed here. You can see here 8 remains 8. So no change here. But once you go 8 to this row to this row, this has been done because of source 0. So this is 0. So what is the path here? We will start from 0, go to 4, then 5, then 6, and then 7. And you can see cost of 0 to 4 is how much? 8. So 0 to 4 you can add it, 8. Okay. And 4 to 5 you know, it's the total cost is 9. So 8 plus 1, so 0 to 5 you can see the total cost is coming as a 9. 0 to 6 you know it's coming as 11. So 0 to 6 you know it's 11. And at last 0 to 7. 0 to 6 you know 11. And at last 0 to 7 you can see 11. And then 6 to 7 how much cost it is there? It's a 10. So it's a total cost is coming 11 plus 10, and that is 21. So what is the path available here? Path is starting from 0, go to 4, then 5, then 6, and then 7. And total cost of reaching 0 to 7 is nothing. It's a 21. If the question asks you about the path, you should go pointer by pointer. Wherever there is change in the cost matrix, you just choose its corresponding selected vertex. Let's say we are here 11. Here the cost was infinity, so there is a change in cost of this particular thing, and this change has been done because of we selected which vertex? 5. So we can take vertex name from here and we can include in the path. That's all for this Dijkstra algorithm, numerical, and this I have done to tell you how it can work even good for undirected graph. Earlier I have told you about directed graph, and this question related to undirected graph. Thank you.